This video provides the basics of writing queries in the Gremlin query language. This video uses an airline routes graph database that contains 3 vertex types: airport, country, and continent. The contains edge identifies the country and continent where the airport is located. The route edge connects airport vertices, and each of the vertices and edges have various properties. Gremlin is the graph traversal language used in JanusGraph, which allows you to query, analyze, and manipulate your graph data. Gremlin contains over 40 traversal step types, but for many use cases, only the more basic steps are necessary. Steps fall into 3 categories: transform, filter, and side effect. Filter steps decide whether to allow an object to pass to the next step. This query uses has and removes every object that doesn't have the airport code LHR. Has label removes every object with a label other than airport. Changing the layout and zooming in, you can see that all of the over 3,000 vertices are airports. Using has and has label together finds all objects with the label airport and the code of LHR. You can combine these two, which essentially requests any element that has an airport label with the code LHR. Transform steps take an object and emit a transformation of it, for example, in, out, and both. This query uses in and returns all vertices with an incoming edge to the CHS vertex, namely airports with a route into Charleston International Airport, plus the country and continent where the airport is located. This query uses in-E and out-V and returns all airports with a route into Charleston. Notice that in returns all connected vertices, whereas in-E specifies vertices connected by a route edge, which would be just airports. This query uses out and returns all vertices with an outgoing edge from DAB, namely airports with a route out of Daytona Beach Airport. This query uses out-E and in-V and returns all airports with a route departing from Daytona Beach. Notice that out returns all connected vertices, whereas out-E specifies vertices connected by a route edge. This query uses has twice, first to filter Boston, then traverse out via a route edge to airports in the United Kingdom. This query uses both and returns the airports, continent, and country vertices associated with Providence Airport. This query uses both E and both V and returns the airport vertices with both incoming and outgoing route edges for Providence Airport. This query looks at all incoming and outgoing edges for the specified airport and retrieves all of the vertices at each of those edges. In other words, all of the incoming to and outgoing routes from Providence. A pending path to the end of the query provides a visualization of all the routes. Side effect steps pass the object and results in a side effect. For example, to return the next object in the traversal step or to iterate through all objects in the traversal. This previous query returns 28 airports. Using next, you can request the next 2 airports. And has next returns true if there are more objects in the traversal. In this case, this query returns true because there is a route between Boston and DFW. This query uses limit to return the codes for the first 20 airports. Or you can use tail to return the codes for the last 20 airports. This query uses values to list what property values are stored in the DFW vertex. Or return just the city name property. In this example, you see the routes from DFW that are less than 300 miles away. Add the by step to return the airport codes and the distance between them. Count is another useful step. This query counts all outgoing edges, or count all outgoing edges for a particular airport. or count the number of outgoing edges labeled root. Use group count to get a count of each type of vertex based on the label value. You can chain steps together like this query, which returns the airports you can fly into beginning in the Austin airport with one stop on the way. Use value map to return all the properties and values for the Austin airport vertex. Gremlin provides a repeat until looping construct similar to those found in many programming languages. This gives you a nice way to perform simple shortest path type queries. You can use the repeat until loop to look for paths between two airports without having to specify an explicit number of out steps to try. This query looks for routes from Austin to Providence and find the reverse route by switching to in E and out V. So that's the basics of Gremlin, but you can refer to tinkerpop.apache.org for complete details. Also check out Kelvin Lawrence's Graph Databases Gremlin and Tinkerpop book at kelvinlawrence.net and his GitHub repo for more information on the dataset. Find more videos in the JanusGraph Learning Center.